Welcome back, kids. And today, some more discrete mathematics, even more abstract, really, I think, than the um, Pascal's triangle. We are going to be dealing with factorial identities. This is very similar to your trig identities, where you were proving one side equaled the other side. Right? You had an equation, but you weren't using equation techniques where you were solving for a particular, you were proving one side is equal to another, so you don't touch one side. And just like with trig identities, you can pick the left side or the right side. And with factorial identities, it's extremely algebraic, which is why this is an HL topic and a BC topic. There actually aren't any factorial identities in BC calculus, not at all. But the algebra manipulation that you're going to be doing with the factorial identities is really going to help you access the tough BC topics, especially in the series unit. So there's really only one fact you need to know for factorial identities. Remember, for trig identities, you had a whole list of, oh, right, I have my Pythagorean, I have my reciprocal, I have my cofunction, I have all that kind of stuff. No, you don't need a list. There's only one fact that you need to know for factorial identities. Remember, we are doing discrete math, so n is an element of a discrete list starting with 1. And you need to remember and realize that n factorial can be rewritten a bunch of different ways. For example, 7 factorial is equal to 7 times 6 times 5 times 4 times 3 times 2 times 1. But that is actually the same as 7 times 6 factorial, right? 7 times 6 factorial. But what is 6 factorial but n minus 1 factorial? So 10 factorial is the same as 10 times 10 minus 1 factorial. And of course, I can keep going. 10 factorial is also 10 times 10 minus 1 times 10 minus 2 factorial, right? Because 10 factorial is 10 times 9 times 8 factorial. And of course, you need to be able to go backwards too. If I see 8 factorial times 9 times 10, I could rewrite that as 10 factorial. An equal sign is a biconditional statement and goes both ways. So if that's true for one starting at 1, then when I include 0, look at this statement. N plus 1 factorial could be rewritten as n plus 1 times n factorial, right? So for example, if n was equal to 7, then 7 plus 1 factorial, which is 8 factorial, could be rewritten as 8 times 7 factorial, right? It's the same thing. It's just whether I want to include 0 or not. So what if I asked you to just simplify? You're not solving, you're not proving, you're just simplifying. What if I want you to simplify this? First, I think to myself, well, what if n was 7? I would have 7 minus 1 factorial over 7 plus 1 factorial. And what would that be? 7 minus 1 factorial is 6 factorial over 7 plus 1 factorial, which is 8 factorial. But that's 6 factorial over 8 times 7 times 6 factorial. What happens to 6 factorial divided by 6 factorial? Bye. And I have 1 over 56. So how does that work for n minus 1 over factorial over n plus 1 factorial? Well, n minus 1 factorial over n plus 1 factorial. Remember, n plus 1 factorial can be rewritten as n plus 1 times n times n minus 1 factorial. And what happens to the n minus 1 factorials? Bye-bye, just like up here. So if it throws you what happens when it's n's, just put a number in for n and say what happens. So this, of course, is 1 over n plus 1 times n, or I could rewrite this as 1 over n squared plus n. What if n was equal to 7? 1 over 7 squared plus 7, but guess what 49 plus 7 is? OMG. Right? So let's move to some proofs. Prove the left is equal to the right, no numbers. But if it throws you, put numbers in. I'm telling you that R can be 0 to 1. So this is my choose statement, right? So this is a way of writing n choose R. This is a way of writing n choose n minus R. So here's my strategy, my algorithm. First, actually write out what that factorial expression is, right? So that's n choose R is n factorial over R factorial times n minus R factorial. Write that out, expand it. Then choose to start on the left or the right-hand side, usually, again, the more complicated side. And then you start thinking, how can I expand or collapse factorials? I want to try to cancel if I have, you're going to have fractions with you have these combination formulas. So can I cancel up and down? Can I get a common denominator and put things together? Right? There's going to be a lot of rewriting. Then simplify and match the other side. So here's step 1. Write out the factorial expression. So n choose R, n factorial over R factorial times n minus R factorial. N choose n minus R, n factorial over, right? Whatever this is repeated here factorial, and then it's n minus repeated there factorial. I decided to start on the right-hand side. So I'm going to leave the left-hand side alone, and I'm going to start on the right-hand side. And notice that all I did was distribute the negative. But when I distribute the negative, what happened to the ends? Done. Multiplication's commutative. Done. QED, baby. Right? That was a good one. Let's do another one. So this time I have a subtraction, and I want to equal just n for any natural number. So remember, this is n plus 1 choose 2, and this is n choose 2. So I decided to start, I'm leaving the right-hand side alone, and I'm just starting with the left-hand side. So I had a fraction, I had a minus sign, and then I expanded. Step 1 was expand the combination formulas to get my factorials in there. Then look at what I did. So notice that the bottom turned out to be n minus 1 factorial. That's what this was. So I just simplified that. And when I did, I looked at the numerator and I said, hey, I can rewrite the numerator such that it has an n minus 1 factorial, right? N plus 1 factorial is n plus 1 times n minus 1 times n minus 2 times n minus 3. And looky what happens there. I'm going to do the same thing on this one. In the denominator, I have an n minus 2, and in the numerator, I have an n factorial. I'm going to expand this out until I stop at n minus 2. So I didn't do anything to this fraction. I left it alone, right? And then this one, this fraction, I got myself to the place where I could cancel the n minus 2's. Bye-bye. Factorials. Look at what I have left. 2 factorial is just 2, right? I could lose the exclamation point. I have a common denominator. Don't forget you have a double negative there. So n squared plus n minus n squared minus negative n is plus n. Bye-bye. 2n over 2. Oh, my Lanta, that's equal to n. QED, baby. Done and done. Don't you feel, I feel pretty good about myself when I'm done with these. Right? It's not like I'm not saving a life or anything, right? I'm not doing anything, but I feel pretty good. Let's do another one. This time I have a sum, and I want to be equal to n squared. I started on the left-hand side, so I'm not going to touch n squared. So step 1 was just do my combinations formulas. N factorial over this n minus 2 factorial, n minus the n minus 2 factorial. Did the same thing here. But once again, notice where in my numerator I've got n plus n factorial, and then I have n minuses here. The first thing I did was, right, n minus n, and then plus 2, that's where this 2 factorial came from. N plus 1 minus 2 is where n minus 1 came from. So that was the first things I attacked. I just simplified those. And that's where the 2 factorial and the n minus 1 factorial came from. Now, do you see what I'm going to try to do? It's kind of same strategy. I have an n minus 2 factorial and I have an n factorial. Expand the n factorial. N times n minus 1 times n minus 2 factorial. Stop, because I now match. N plus 1 factorial can be n plus 1 times n minus 1 factorial. Stop, because I match. And again, let me just stop for a minute and tell you, pretend n is 10. If n is 10, 10 factorial is equal to 10 times 9 times 8 factorial. But 9 is 10 minus 1, and 8 is 10 minus 2. Right? That's the thinking that I'm doing. Now notice what I'm going to do. Bye. And once again, I have fractions with a denominator of only 2. Distribute. Combine. Bye. 2n squared over 2. Cancel out the 2's. And I get n squared. Woohoo! I just can't get enough of these. Let's do another one. I have a sum. I've dealt with that, but this time I'm equal to another combination. Ooh, I've got 3 combinations. So the first thing I'm going to do is expand all the formulas. Whoa! But that is nothing, right? That is just n choose r, n choose r plus 1, n plus 1 choose r plus 1. Where do you want to start? Left or right hand side? Now, I did change, but I just simplified this. So I'm not really manipulating this yet. It's just, right, I just distributed my r and my 1. So I'm, right, this my plus 1 and minus 1 here. That's where I got this n minus r factorial. And I did the same thing here. Right, I didn't manipulate, I just distributed and combined. Ew, this looks messy. So I am just going to start with the left-hand side, right? So forget the right-hand side. I'm just got the left-hand side here. And I haven't done anything. I just copied it over. Notice again, though, that I have n factorials in the numerator and I have n minuses in the denominator. What happened there? I'm going to give you a moment just to look at it. What did I do? So notice in the denominators up here in this step, I have an r factorial, I have an n minus r, and I have an n minus r minus 1 factorial. In this denominator, I also have an r factorial. I also have an n minus 1 n minus r minus 1 factorial. So in other words, I have two fractions that don't have a common denominator. So I can't put them together. And my whole thought of like, well, I could do the n minus stuff. Well, I can't really do because this is n minus an r and then this is n minus r minus a 1. So that's not going to work. So the only thing I could think of was to get a common denominator. So look at this first fraction. It's missing the r plus 1. So I multiplied the first fraction by r plus 1 over r plus 1. And I multiplied the second fraction by n minus r over n minus 1. N minus r over n minus r. So both fractions are multiplied by 1. But now look at my denominator. Right? That's just fractions, honey. That's just elementary school fraction work. Now my denominators are the same. So what can you do with two fractions that have the same denominator? I'm running out of room, so I'm going to go to the next slide. No, not yet. Next time. I can put it all together. N factorial times r plus 1 plus n factorial times n minus r, all over my common denominator. Now, don't you go cancel anything, right? You can't cancel. You have this plus here, so you can't be like canceling out those groups. I put the right-hand side back to remind myself of where I'm going, since I kind of changed my, it's like I flipped a paper. So now look at what I'm doing. What did I do here? Factor, baby, right? The good F word. I took the n factorial and factored it out front. When I factored it out front, what was left? R plus 1 and n minus r. But look what happened to my r's. Those are going to go away. Now I want you to look at this scenario. This is hard to see until someone shows it to you. This is n minus r, then it's n minus r minus 1. Think about that. 10 times 9 factorial, or 10 times 10 minus 9 factorial. How can you rewrite that? Aren't both of those the same as 10 factorial? So look what I have here. 10 minus r, and then 10 minus r minus 1. So I still have my r factorial. I still have my r plus 1. But n minus r times n minus r minus 1 factorial collapsed back into just n minus 1 factorial, n minus r factorial. Why would I want to do that? Look at where I'm trying to go. Where I'm going had an n minus r factorial, so I'm part of the way there. But now look at what I have here. R factorial times r plus 1. What is that? Well, again, pretend r is 7. That's 7 factorial times 7 plus 1, which is 7 factorial times 8. But isn't that 8 factorial? So guess how I'm going to rewrite this? I had my n minus r factorial, and now I got my r plus 1 factorial. Oh, snap. My denominators match. Now I just have to get my numerators to match. Well, do you see what's happening there? N factorial times 1 plus n factorial is the same as n plus 1 factorial for these same reasons. Whoa. Done and done. Right? That one was a more complicated one. And I do understand your eyes get blurry, your R's, N's, ones, minus R's. What the heck? I get it. I do. Just takes practice, right? You do have to kind of slow down with these and make sure. Highlighters, colored pencils, they're all really great to use with these. All right, well, have fun with these. And I will see you in our next live session.